Hello everyone, I'm James and welcome to episode 7 of the OpenGL tutorial series. Today we're going to be doing texturing. Texturing gives a lot of life to our scene. For example, we can make stone texture or wood texture. How can we get the texture on our cube? Let's begin.
Let us go back to a simple quad. Right now we are outputting the vertex position as a color in the fragment shader. What is interesting though is that between the vertices the vertex position is interpolated, which is why we get this gradient effect. When a varying variable is passed from the vertex shader to the fragment shader, it gets interpolated. With that in mind, how can we apply a texture on the quad? OpenGL has a function that samples a pixel from a texture, and we can then output that color in the fragment shader. So from where are we going to sample the texture? If we are at the top right corner of the quad, we would want to sample the top right corner of the image. If we are at the top left corner of the quad, we want to sample the top left corner of the image, and this applies in the same way to the bottom right and bottom left. The way we can make all this work is by storing what are called texture coordinates in the vertices. So each vertex will have a texture coordinate, which is a two-dimensional vector. Then we send these texture coordinates as varying variables to the fragment shader. This will interpolate these coordinates in the same way the vertex position got interpolated, and we get the effect we want.
Let us add these texture coordinates to our vertices.
The first thing we'll do is create a vertex struct. I'll add a field for the position. I'll add another field for the texture coordinates, which I'll represent with a two-dimensional vector. Textures are usually two-dimensional, however there are cube maps which aren't actually two-dimensional. We'll cover that in another video. I'll add a constructor which initializes these fields. We now need the mesh constructor to take in a vector of vertex instead of glm vec3. We'll obviously do the same for the definition. When setting the vertex buffer data, we need to make sure that we pass the size of the vector multiplied by the size of vertex. Now we finally come to the time where we'll add a new vertex attribute. So we'll first call gl enable vertex attrib array with 1 as the index parameter. Next we'll call gl vertex attrib pointer. The first parameter is the index, so we'll pass 1. The second parameter is the size in floats. Texture coordinates are 2D, so we pass in 2. The third parameter is the type, in our case float, so we'll pass gl float. The fourth parameter tells OpenGL whether we want to normalize the vector or not. We don't want that, so I'll pass gl false. The fifth parameter is the stride, which is the size in bytes of the entire vertex, so we can pass size of vertex. We need to also change this for the position attribute. The last parameter is the offset in bytes, which we can easily get using the offset of macro. The offset of macro gives us the offset of a field in a class. The first parameter of this macro is the class, in our case vertex. The second parameter is the field we actually want to get the offset from, in our case text chord. We'll need to cast the result to a void pointer. For consistency, I'll also use the offset of macro for the position attribute. In the main file, I'll uncomment the code that made the quad. I'll change the vector of positions to a vector of vertices. These are the texture coordinates I'll be using. For now, I'll comment out the cube and where it's drawn. Remember to draw the quad instead.
I did a couple of things. First of all, I disabled face culling because I want the quad to show from both sides in this case. Also, I commented out the create cube method because if you don't, it will give you a syntax error because it's still using glm vec3s for vertices. If I run, we get the exact same result we had when we had the quad previously. So what can we do to get it actually textured? So we've added the framework for texture coordinates. However, we didn't do anything to get a texture loaded onto the GPU. The way we load it onto the GPU is very similar to the way we load a vertex buffer and index buffer. However, it's a bit different because you have to specify the width, the height, and certain other parameters that don't apply to the vertex buffer and the index buffer. Let's go ahead and get started.
I added a texture class in a header with the same name. The first two parameters of the constructor are going to be the width and height. The third parameter is going to be an array of bytes representing the pixel data. The fourth parameter is going to be the format the texture is going to be stored in. The fifth parameter is going to be the format of how OpenGL will treat the texture. The sixth parameter is going to be the way we want to sample the texture. I will default this to GL linear. This means that when the texture is stretched, the texture will be linearly filtered. The final parameter is going to be the wrapping mode. This will specify what happens when the texture is sampled outside of the bounds. I'll default this to GL repeat. This will tile the texture. We'll add a destructor and a bind method. The bind method will tell OpenGL to use the current texture. It will take in an integer parameter which specifies which slot we want to bind the texture to. There are multiple slots. Because it is useful to bind more than one texture at once, this will be apparent when we do normal mapping. I'll also keep track of the width and height of the texture. We'll also need a private field to store the ID of the texture. Now let us implement the constructor. The first thing we'll do is initialize the width and height fields. Now we'll create the texture by calling GL gen textures. The first parameter is the number of textures we want to create. We only want one. The next and final parameter is a pointer to an unsigned integer. This will set the location that the pointer is pointing to the ID of this new texture, which in our case is the address of MID. Next we'll bind the texture. The target is going to be GL texture 2D, and the ID is obviously going to be MID. Now we'll tell OpenGL to use the sampling mode we chose and the wrapping mode. The last thing we'll do in the constructor is actually send the texture data to the GPU. We do this by calling GL textImage2D. The first parameter is the target, which is once again GL texture2D. The second parameter is the level. To be honest, I'm not sure what this does. I never used it. We'll set it to 0. The third parameter is the internal format, so we'll pass the internal format variable. The fourth and fifth parameter are the width and height of the texture, so we'll pass width and height. The sixth parameter is the border. I'm also not sure what this does. We'll set it to 0 as well. The seventh parameter is the format, which we'll simply set to the format variable. The eighth parameter is how we want the pixels to be stored. We are going to store them as unsigned bytes, so we'll pass GL unsigned byte. The final parameter is a pointer to the pixels, so we'll pass the pixels pointer. The destructor is very simple. All we have to do is call GL delete textures. The first parameter is the count of textures we want to delete, in our case 1. The second parameter is a pointer to an array of texture IDs. We only have one ID, so we'll pass the address of MID. The bind method is also very simple. We need to tell OpenGL which slot we want to bind to. We do this by calling GL active texture. We pass in GL texture 0 if we want to bind to slot 0. We pass in GL texture 1 if we want to bind to slot 1. We pass in GL texture 2 if we want to bind to slot 2, and so on and so forth. These constants are in ascending order, so if we do GL texture 0 plus 1, we would get GL texture 1. So what we can do is activate GL texture 0 plus the slot we want to bind to. Next, we'll bind the texture in the same way we bound the texture in the constructor. In the main file, I added this code that will generate an image with random colored pixels. First, we'll import texture.hpp. Next, I'll create a texture, the width and height both being texture size, the pixels being the array of pixels. I'll set the internal format to GLRGBA8, which means 8 bits for each channel. I'll set the format to GLRGBA. I leave the last two parameters as default. Next, I'll bind the texture at texture slot 0. Now let us use the texture in the shaders. The first thing we need to do is add another attribute for the texture coordinates in the vertex shader. The location is 1 and the type is a two-dimensional vector. Instead of outputting the position as a varying variable, I'll output the text chords. In the fragment shader, we'll take in the varying text chord. I'll add a uniform of type sampler2d. This is a special uniform which gives us access to a texture. Finally, I'll sample the texture with the texture function and output the color to the fragment shader output. The first parameter is the texture we want to sample from. The second parameter is from where I want to sample the texture. In our case, the texture coordinates. Right now, this will probably work. However, later it will be important to tell the shader which sampler slot we are using for the texture uniform. In the shader header, we'll add another setUniform method, this time taking in an integer instead of a 4x4 matrix. In the definition of the method, we'll get the uniform location in the same way we did for the 4x4 matrix. To set the uniform, we'll call glUniform1i, passing the location as the first argument, and the value for the second. In the main file, right after we bind the shader, I'll set the uniform uTexture to 0.
So now if we run, there you go, we get a texture on our quad. Awesome. I added a texture load method. This loads a texture from a file name, and yeah, there you go. So now you can load textures. Loading an image in C++ isn't the easiest thing to do. However, thankfully, there is a library called stbimage which makes loading images very easy. I leave a link to the GitHub page in the description. I also brought back the createCube method, however I changed it slightly to work with the new system of texture coordinates. That will also be available on GitHub. In the main file I'm using the createCube again, and instead I'm loading the texture and I'm loading bricks.png. I also put back the transformation effect back. Now if we run, look at that. We have a cube in 3D space with a texture of bricks. Awesome. And that, my friends, is the end of this video. In the next video, we're going to be doing a big refactor. We can't keep on going like this, otherwise we'll end up with a spaghetti carbonara. If you want to be notified when the next video is coming out, please consider subscribing to the channel and hitting the notification bell. Thanks for watching and goodbye.